So, hello dear students, welcome to my problem solving session. Today we will solve the hardest question in electricity chapter. So, let's dive deeper into this problem. So we have given here three charges, Q1, Q2 and small q. And the charges are the same sign, like positive, they are all positive or negative. Yeah? Let's consider positive. So Q1 and the Q2 is connected each other with rod. Here is rod, and there is from this rod there is a point here, O. There is a O point here, and from the O point, Q1 is located in L1 distance, Q2 is located in L2 distance. So also there is a thread which has length R, and this thread is deflected by beta angle here. Yeah. And in the end of this thread, there is a small q, and the system it states that the system in equilibrium, meaning that net forces equal to zero. The sum of the force equal to zero. So here the first question is we need to find Q1 here. Yeah, Q1. So let's draw a free body diagram here. There is a Q1, there is a point O, and there is a Q2. And the thread is tied to point O. The deflection beta angle is Q, small q. And as we said earlier, the charges are the same sign. So the same sign charges will repel each other. So we will consider here the forces on small q. We can also consider on Q1, but it's better to use forces on small q. I will explain later. So let me change the color of this pen. So the Q1 will exert the force in this direction. It will be F1. In this direction, it will be what? F2. Yeah, the all forces are repulsive forces, not attractive forces, repulsive forces. So let me write here the formula of them. F2 is equal to K Q2 small q over this R2 distance square. F1 equal to K Q1 small q and the R1 square, which is R1 distance from this point to this point. Yeah. So we have defined here forces, but there is also tension force. If we consider this tension force, our problem will get harder to solve for us. So to simplify this problem, we here take this reference like as a x direction, and the y direction is exactly perpendicular to this x direction. Yeah, we can avoid by making this like line x direction to avoid this tension force. By doing this, we avoid tension force, and we don't use tension force. We use only the F2 and F1 forces. Okay. So here we define the y and the x components, but x components we don't need any more x components. So because the net x is 0, because we here don't consider tension and the x components of the F2 and F1 forces. So we need only y components, and but according to vector's law, in this direction will be F2 y force. In this direction, F1 y force here. It's 19 degrees. It's 19 degrees. We have defined here y components of the F1 and F2 forces. Okay. So there is we can label it as an angle, because F1 y component is F1 is like there is an angle alpha. Let it be alpha, but we don't know alpha, and according to geometry knowledge, it's also alpha. There is a angle gamma. There is also angle gamma. Okay, according to geometry knowledge. So F1y, we can find this F1 force, y component of the F1 forces by multiplying F1 by cosine, by sine alpha. Yeah, it's the same scenario. F2 multiplied by F sine gamma. We define here the components of forces. So the question is, we don't know gamma and the alpha angles. So what will we do? Will we be solving according to geometry laws, according to very wonderful law, wonderful theorem, cosine theorem. We use cosine theorem. So according to cosine theorem, there is L1 here, there is L2. It's in the radius here. According to, we can find R1 according to cosine theorem. R1 square here is L1 square plus R square minus 2L1 R, and the angle between these two walls, cosine beta. It's cosine theorem for R1 distance, and for R2 distance, this like, yeah, it will be like theta, yeah, theta angle. Let it theta, and means 180 minus beta. It gives us theta angle. So it would be L2 square plus R square minus 2L2R multiplied by cosine 180 minus beta. So it gives us minus cosine, minus, and the minus gives us plus. It will be in this 2L2R cosine beta. So we have defined here what? We have defined here R1 and R2, yeah? R1 and R2. So we need to find here sine alpha and the sine gamma. How can we define, how can we find them? According to sine theorem, according to geometry knowledge, of course, sine theorem states that there is a sine alpha. Let me change the color of it, like this, purple. Sine alpha to opposite, it's over opposite wall L1, and sine beta opposite to R1. Sine beta opposite R1. From this we can find sine alpha. It will be L1 over R1 multiplied by sine beta. Yeah, do you agree with me? If not, you can leave a comment. The same scenario in this triangle. Indeed, we divided here into two triangles to simplify the problem. There will be sine theta over R1, and here sine alpha over L2. Yeah, sine gamma over, yeah, sine gamma, yeah, sine gamma over L2. Sine gamma means here L2 over R2 multiplied by sine theta. Sine theta is 180 minus beta. It gives us L2 R2 sine beta. Yeah, we found here sine alpha and the sine gamma. Yeah, and also we have found here R1 and the R2 distances. So here we can define that net force in y direction is 0 because this charge is not moving. Okay, so 2y minus f1y equal to 0, yeah? And we can put these values here. If it means that they are equal in magnitude but opposite in direction, so it will be okay, q2 small q r2 square. It will be here what sine gamma we have here, sine gamma L2 over R2 sine beta. Here we define here force 1 q1 small q R1 square L1 R1 sine beta. Sine beta and sine beta cancelled out. Also k and the q small q, yeah. We have here what, let me change the color. Here we have q big q2 multiplied by L2 and the R2 insert prime and the q1 L1 and the R1 in 3. So we need to find here q1, big q1. We can find it by this way, L2 L1, yeah, and the R1 insert R2, yeah. Do you agree with me? Yeah? So according to this formula, we can put here. We have here q2 and the L2 over L1. There are given values here, given, and we need just put this R1 from this and the R2. Okay, let's put R1 is this, but it's in square. We can put here L1 square r square minus 2L1 r cosine beta, yeah. So below L2 square plus r square plus 2L2 r cosine beta, but they are all in squares, so we can write it as this. Okay, 3 divided by 2, yeah, in this prime. So it's an answer. There is no unknown values here. L1, R, and the beta angle, they are all given. They are all known. This is our answer here. So the second question is, let me summarize this problem solving. We here use just geometric knowledge, okay, just geometric knowledge and the physics. From physics, just we put here forces, column forces, yeah. If you know very well geometry, you can solve this problem easily. Okay, it's not hard as you thought. So the second question: what magnitude of charge Q1 can be measured in this way if L1 equal to 2L2 and the R equal to 3L2, yeah? So the second fragment of this problem, what will be the magnitude of Q1 if L1 is 2L2 and the radius, the length of thread is equal to 3L2, yeah? So according to this question, let me explain that we need to find here a minimum value and the maximum value of this charge. Minimum value occurs when beta is 0, yeah, and the maximum value occurs when beta is 180 degrees, yeah. So the first question, Q minimum, yeah, Q1 minimum, we can find according to this. Q1 equal to, it's a calculation, it's a long calculation. So let me calculate fast. Here to the L1 to L2. There is 4 L2 square plus 9 L2 square minus 2 2L2 3L2, and cosine in 0 is 1, yeah, it gives us 1. Put here also the same. Yeah, we can calculate here Q2 L1 here, yeah? Not L1, not L2 here, L2 over 2L2. It's 13 L2 square minus 4, yeah, 13 L square minus 4, it's 12 L square. No, L square. It is 25 L square. It's not mistaken. So it's cancelled out. There is Q2 over 2. It's over 2, and then it's like L2 square. Yeah. 1 L2 square over 25 L2 square gives us what? There is a it gives us what it's also in this prime. I forgot to put this value. It gives us what? Yeah, because it cancels out Q2 2. It gives us like this. $25 insert. It gives us, it's like no. Should be in this 25 insert. It gives us Q 2 in it will be 5, yeah. Let me calculate this. 5 in 2, 5 in 3, 5 in 2 with 2. It gives us yeah, is it correct or not? Is correct. So I have mistake here maybe, and we can find, just putting this all calculations, we can find here Q here, what Q max here, it's Q min. Q max equal to Q2 is, yeah. So we see how found here all values. So it's a long problem solving. So thank you for paying attention. Okay, just put we can solve by yourselves this second chapter, the second fragment of this problem. So good luck. I hope that you will do very well here.